Evening, everyone. Can you hear me?
Yes, Tushar.
Okay. Okay. Today's workshop is related to the Plaxis, and I will give you a brief introduction about the Plaxis and how you are going to model a square foundation in the Plaxis. If you observe here, I already brought an example which is in front of you. If you can see that one, it's a square foundation and we have to model this square foundation in Plaxis 3D. Soil parameters are with us, which is saturated unit weight is 20 kilonewton per cubic meter, dry unit weight is with us. Modulus of elasticity of the soil, Poisson ratio, cohesion, angle of friction, and dilatancy angle. Now, we all know that to solve any problem of the geotechnical uh, or the soil problems, we need the material properties of that soil. Now, I'm considering here one soil, and we have to construct a foundation of 3 meter by 3 meter on this soil profile. So what I'm considering, the area is 30 by 30, and the size of the foundation will be 3 meter by 3 meter. Now, our main task here is to get the bearing capacity through the Plaxis software. Now, if you observe here, whenever you are modeling any problem in the software, so, usually we try to use the concept of symmetry, axis symmetry, or we try to model them using the symmetries so that we will have number of elements less for finding the solution. Now, if I'm going to model this whole as a problem in Plexus, what is going to happen? The computational time will increase, number of elements will increase. Ultimately, we know that if I know the solution of this quarter of the soil and the foundation, it will be similar on all other sides if uniformly distributed load is applied on this foundation. So what I'm going to do is I'm going to take only quarter of this portion so that I can reduce the elements in the software and as well as the computational time. Now, if you see here, I just showed you the cross section of the soil and the foundation. So this foundation is resting on the soil at the ground level, and this is the domain of the soil, and the water level is far away from that one. And I will show you how we can model the water table in this soil profile, or how we can move that water table away from the domain. So by modeling this one at the end of the solution, when I will get the solution through the plexus, I will compute the bearing capacity, and I will compare this bearing capacity with the Terzaghi equation. So already I have shown the verification here. So the results are there. So I will just inform you uh, that one. Okay, Ali, the question, we will answer this question at the end. Now, size of the footing is 3 meter by 3 meter. So I'm modeling the quarter of that one. So it is 1.5 meters. So when I will take quarter of that one, this dimension is 1.5 and this dimension is 1.5. So this 1.5 is representing this quarter part of the foundation. So kindly guys, the questions will be at the end so that I can convey my message fully and I don't want to disturb the recording because you guys have to see the recording later on. So if you ask the questions now, it will recording will be very long and it's very difficult for you later on to catch everything. You have to skip and run here and there. So better let me just start with that one, and then we can have the question and answer sessions at the end. Okay. Okay, so I have to model this quarter part in the Plaxis. Now, the size of the footing which I have to model in the soil is 1.5 by 1.5. Soil domain, I'm taking 15 meters of the soil from this side and 15 from the other side. And the depth of the layer of the soil, I'm considering 25 meter. And you can consider this is one layered soil. Now, why I'm going deeper into the soil, you know that the stress bulb usually under the foundation, it reaches up to 2 times the width of the foundation. Now, width of the foundation here is 3 meter. So 2 times 3 will be around 6 meter below the foundation. Our stress bulb will form and we will have maximum stresses up till 6 meter. And furthermore, from that one, the stresses will become zero almost or nullified. So this is our profile which we have to model. So I will go to the uh, screen and you can see here, this is the software Plaxis 3D, and I will just click on that one and I will open this software. Now, when you open this software, this will be the profile of the software. You will find a new window saying that you have to start a new project, open any existing project, or you have any other project which you are doing part by part, you can open that one. Now, in our case, we have to model it as new. So I will click on a new project. When you click on the new project, first window will appear and it will always ask about the title of the project so that it will be saved through that name. So I can call it as square footing, okay, modeling. Then if you see here, there are three tabs at the top of this project properties. First one is the project detail where you have to write about the project title and other things are not mandatory. It's just for preparing the report, you whether you want to write it or not. It has nothing to do with the title. Now, next thing I have to click on the model. Now, when you click on the model, it will give us certain properties, what type of model you have to use. Are you going to model it as full number of noded elements? Now, these elements, number of noded, you usually you need to take finite element course, which gives us the description about the multiple elements available for the finite element analysis. Now, here you don't have to worry about that. Even if you don't have the knowledge about the elements, you just keep it as default. After that, you have units, which is meter. Force, we are going to put kilonewton. And the time, I will use days here. These are default options. I will not change them. And stress units will be kilonewton per meter square. Unit weights will be in terms of kilonewton per cubic meter. Now, we know that gravity of the earth is 9.81, so we will not change that one, and gravity is going to be act in z direction. So if you observe here, axes are shown, x and y is representing the plane area and z is representing downward direction. Now, I need to give the geometry of the soil in how much block I have to consider in the modeling of our problem. Now, if you remember, I said that I'm going to use quarter of this one, which means that I need 15 meter in X direction, 15 meter in Y direction. So what I will do, I will go and model in Plexus. I will start from 0. 0 is representing this origin. And I will go to the X direction, 15 meter. And then same, I will go in the Y direction, 15 meters. So I'm just giving the area for the time being. I'm not modeling the depth here. So I'm just modeling only the area geometry in this one. Then I will click on OK. Once you click on OK, this area which you are observing here, it is 15 meter by 15 meter. Now, next task, we have to define the depth of the soil, and the depth of the soil is defined through the bore hole. So if you observe here on the left side of the screen, there are multiple options. When you bring a cursor here, it will give you the names of the icons. Now this icon is related to the selection. Then you go to the next one. It is related to the moving of the object. If you already can model something, you want to move that one. And then if you want to adjust the soil contours, after that, you will find create borehole, and the next option here is import soil. If you have already model soil block available with you, you can just import that one. But here, I'm just going to model it from the scratch. Next is the material. So let us go to the borehole. Borehole, basically, usually you are taking bore in the downward direction from the ground level. So that's why they are using borehole option here for the depth. When you click on this one, you need to select a node where you want to define the properties of the soil in downward direction. Usually, you can go with the origin. You can click on 00 node. You can see here when you move a cursor, it's giving you the nodes. So you can click on 00. Once you click on 00, a new window will appear here which will ask about the soil layers. Now, if you have multi-layers, you can just come add here or delete those multiple layers. Now, in this case, our soil profile here is only one. So what I'm going to do is I'm going to model only one soil layer. Now, what is the depth we have to model in our problem? If you observe here, I'm considering 25-meter soil profile. So I will go back to the axis. I will plug here. So top, I'm starting from 0, and bottom of the soil, I'm taking it as 25 meter. When you click on 25 here, okay, sorry. Another issue here, because why it is not taking a number, because my origin is 00. When you say positive 25, so it will not select or take it as a number because it's something upward, that there is no soil available. So what I have to do here is we have to plug it as minus 25. When you click on minus 25, you can see here a borehole is shown to us on the left side of the screen. Now, if you observe here, there is these symbols which we have used in the class, which represents what? Water table. Now, in our problem, water table is not at ground level. And I said that water table is far, far away from the foundation. So I need to change the head here. So head is representing the location of the water table. So if you observe here, when I put 1 meter, negative 1 meter in downward direction, this head is changing, means water table is now 1 meter below the ground level. Now, in our problem, water table is far away from the foundation level. So what I'm doing is I'm keeping it minus 25 so that this water table is not available in between the soil bore data which I'm modeling. So there is no water in this region. Water is just 25-meter below the foundation. Now, next thing in this window, you can see here, there is a material to assign. Now, what is that material? Material is related to the soil. So I need to add a material here. There are two ways of that one. You just click and there is a plus button which gives you add new material. One option is this one. Other is you can just go and click on the materials, which is available in the second button here. You can just click on this one. You will find a new window appear which shows us soil and interface. Now I need to define soil here. So I will click on new. Once you click on new, it will open a new window in front of us where we need to name the soil. We have to give the unit weight of the soil, unsaturated, saturated. Then we have to give the mechanical properties of the soil, which include modulus of elasticity of the soil, angle of internal friction, Poisson's ratio, all those properties. So I will call this as soil because I don't have detail available for this material. Is it sand or nothing? We have just soil profile. Our soil parameters are given to us. So I'm just naming it as soil. So you can name it anything. Now, next thing is soil model. Now, there are different models are available for these non-linear materials because soil is a non-linear material. You can model this soil as Mohawk Coulomb, uh, and you have gone through with the stress curves which you have learned in soil mechanics, Mohawk Coulomb uh, circles. So these circles which you learned there, they were giving us about the shear stresses and the normal stresses computation. So these are some models which give us the behavior of the soil. Now, our soil is not a linear elastic and it's a non-linear material. So we can get all these uh, non-linear capturing through these advanced level of the models, which are small Coulomb, Hook Brown, rock, soil hardening, HS small, or if you have a clay, you can use these available models. So here I'm using the simplest model, which is the first model developed for the non-linear materials. So we will use more Coulomb here, and I'm considering the type of the soil. There is a drain, it's a drained soil. Next, I need to give the unsaturated unit weight, which was 18 kilonewton per cubic meter, and saturated unit weight was given to us 20 kilonewton per cubic meter. And I'm not changing the void ratio initial, or if you have that one, you can change that, but we don't have that data. We have only unit weight, and I will not play with these properties. I will leave them as it is. Next, we need mechanical properties. So I need what modulus of elasticity of the soil. So if you go to the slide, you can see here the modulus of elasticity for this soil is given to us, which is 1.25 into 10 to power 5. Poisson's ratio is zero point 0.3. So I will use these properties there. So 1.25 uh, E, which will give you 10 to power 5. So you can plug here 5. Then new was Poisson's ratio was zero point 0.3. Next, we have to give the angle of internal friction and cohesion. So if you see in the statement, cohesion is given to us 10 and angle of internal friction is 35. So I will use that properties here, which is 10 and 35, and psi is 0. So by default, it will take 0 if you don't put any number for these locations. Now, we don't have groundwater, so I will not go to the next property. I will not play with that one. But if you have a groundwater available, you can go and change the type of soil. Is it coarse, medium, fine, organic? It depends on the properties available with us. Then permeability coefficients, if you know that one, porosity and unsaturated zone, if you know all these properties, you can play with that one. But we don't have groundwater, so this property is not affecting us, or you can leave that as it default. It will not uh, play an important role in our calculation. Then there is an interface. It is interface between the slab and the soil. Now our slab is directly resting on the soil, so I'm not modeling any interface between them. And last is the initial. Now, if you observe here, this initial is related to the self weight stresses calculation. If you have there is no applied stress on the soil, so the properties of that one will be computed you through the Rankine static coefficient. So if you observe here already, that Rankine coefficient is already computed based on a phi angle of internal friction, which we gave in the beginning. So you can check 1 minus sine 35, already automatically it is computed. So we don't have to modify them because it's already computed. If you have some different k values, you can use the manual option, but we know that k value depends on angle of internal friction, and k static is 1 minus sine phi with the formula which we saw in our class. So automatically it is computed. So I will say okay here. When you say okay, you can see a soil is appearing here, and you can click OK. Now you can come and assign a soil profile. So when you click on this one, you can see here the whole data color has been changed to soil now. Before it was just a geometry, now it becomes a soil profile. So after that, you just click on OK, and you can see here this is the block which we model uh, for the soil. Now, after modeling the soil part, we have to assign the loads on that one. And if you observe here on the left corner at the top, you have some options shown through the arrow. So first was soil, which we have already completed. Next, I need to click on structure. Now, structure includes your foundation and the loads on the foundation, or the displacement, or the forces which you want to apply. Now, first of all, I need to model the foundation here. Now, as I was modeling 1/4 of that one, so I have to model foundation here 1.5 by 1.5. Now, if you observe, there are multiple options here. Again, if you bring cursor on that one, you can see the options which you might have observed in your AutoCAD also, related to extrude, copying, selecting, and line if you want to create a line, or you want to create a surface. Now, what I'm going to do here is I'm going to use a surface option to model our foundation. Because our foundation is rectangular or square, you can use this surface option to model that one. When you click on that one, you can see here now you will find a node is moving along with your cursor. Now I will start my first point from 0, 0. Now, if you don't find, now our foundation size is 1.5. If you see here, when you are moving cursor, it's not giving you 1.5. So you are getting 0x, 1y, and 0z. If I move to the next, I'm getting 2. Now, the thing here, what you can do here, you can quickly draw a rectangular area. When you do that one, by press, once you finished any rectangular area, you don't need to press enter. What you can do here, when you are creating this one or two nodes, quickly a window will appear on the side of your screen, where you can change the ordinates and you can get your required area. Now our first node is 0, 0. Next node should be 0, 1.5. So I can edit directly from here. You can see here on your screen that now the nodes are moving. Now I can move to the third one, which is 1.5 by 1.5. Okay. And the last one will be 1.5. So this is how you will get your rectangular area once you get your nodes properly. So this is 0 0, this is 0, 1.5, then 1.5, 1.5, and 1.50. Y and z is all 0 along that one. So you can just say okay, or you will see that a surface has been created here. Now, as we know that our slab system is resting on the soil at ground level, so I will not model it as a plate. What I will do, I will directly apply load on this surface. If you have a plate which you want to model in your software, you want to give the properties of the concrete, then you need to model it as a plate. You need to give the thickness of the plate, which is your slab, and you have to define the material properties for the concrete. But in this case, because it's the simplest problem we are solving here to get the bearing capacity, so I don't need to apply any plate condition on this one. So what I will do here is I will just consider this as a surface, and on that surface I'm going to apply a load, whether in terms of forces, uniformly distributed load, or in terms of displacement. Now, once you define your surface, next thing is to assign the load. Now, if you see, there are different options available here. You have create a load. Now, when you click on that one, you will find a point load, you will find a line load, you will find a surface load. So depending on the type of load available in your problem, you can select the surface and you can apply a point load. For point load, surely you need a node on a location where you want to apply a point load or a point moment. So in this case, there is no detail available with us whether there is a load acting on this foundation. Here we have to just find the bearing capacity of that one. Now, how you are going to get the bearing capacity? If you remember in Terzaghi equation, all it depends on the soil profile. Now, in the software, you have two options. What you will do, either you apply a load con in intervals and increase that load until this soil fail. Now, the failure of the soil actually give us the bearing capacity. So we have one option, either I can apply a area load and increase that area load in increment until this soil block will fail. And once the failure or in the soil block happen, I can consider this as a failure, and that will be the bearing capacity or maximum load carrying capacity of that soil. Another approach is that you apply a displacement in this surface. Means you apply a displacement. If you remember from your structure analysis, if either I can apply a force to get displacement, or I can apply displacement to get forces. Now, what I will do here, displacement control analysis is much control than the force based analysis. So I will apply a displacement on this surface, and I will say that I will push this soil around 200 millimeter into the ground. And if I'm applying that displacement, there will be forces produced inside the soil, and the soil will start failing against that forces. So what I will do, there are two options. Either you can click on this to create a load, or you can describe a displacement. You can assign some predefined displacement or settlement in that soil. So there is an option, either you click on this one and go and select the nodes, lines or surface. You can use this option, or you can just right click on the surface. You will find an option, create displacements, create load, create discontinuity. So you have multiple way of assigning the load. Either you can use these options, or you can just right click on the surface and come to the create, and you can assign a pre-described displacement. Now, when I will click on this one, you will see that there is some symbols, arrows showing downward, which indicates that we are going to apply a displacement on this surface. On the right side of the screen, you will find a surface displacement. You can click on this one, and when you open this tree, you will find that one displacement in X direction means free. It is free in X direction. In Y direction, it is also free. And in Z direction, prescribed value, uniform displacement. Now, I will not displace this soil up to 1 meter because 1 meter is too much. What I will do here, I will make it like 0.2 meter displacement in downward direction. So I will put minus there, and I don't want the movement of this surface in X direction and in Y direction. So what I will do, I will create this fix and fix, so that this surface will not move in X direction. So there will be no displacement in X direction. There is no displacement in Y direction. Only this surface will move downward 0.2 meters. So this is the pre-described displacement I'm applying on that one. Once you do finish with the displacement, next thing is you have to define the mesh. Because I'm not defining here any plate, so you don't have to define a loading plate here or give the properties of the concrete. I'm directly considering that the load coming at the base of the footing is directly applied on the soil layer. Next is mesh, which we need to divide this soil into small elements so that we can get a solution of that one. So if you observe here, there are different options available for mesh. First is refined mesh. More is the finer mesh, more accurate results from the finite element is there. If you have coarser mesh, less accurate results are there, but it is acceptable depending on your computer or specifications. You can make it finer because it will run quicker. If you make it coarser, you can reduce the computational time. So that's why we need a finite element course to give you the understanding of these elements. Now here, I know that majority of you don't have a background on that one. What I will do here, I will use the mesh option. And if you observe here, there are different options available for the meshing. I will go to the generate mesh. When you click on generate mesh, which is the default option, will give you medium meshing. Now you have an option of very coarse elements. You have coarse element, then medium, fine, very fine. So more I go to the finer, more computational time it will take to solve the problem. So in this case, I'm assuming it as medium, and I will say okay. Next, I need to click on view mesh. When you click on this one, it will create a mesh and show us the division of the soil profile in small elements. So you can see that the the Plexus have done the soil profile, divided the soil profile into small elements. So now uh, Plaxis will solve each one element one by one and give us the results for each element, and then you can get the contours for each element and for the whole profile. Now, this is what we did. If I just show you back, I will go back to that one. I will regenerate some coarser mesh. I just want to show you what is happening in that one. If you choose a coarser mesh, you can see that one bigger elements are there. Now, when you have these bigger elements, computational and time is less, but the results are not accurate. So we prefer to have finer meshes. So I will just change back it to medium, and I will convert this all into medium mesh, and you will see number of elements has been increased. The section has been divided into more triangular and rectangular elements. Now, once you finish with the mesh, next thing is we need to apply the load. Now, this is just the meshing. Still, your problem is not yet completed. So what is the next task? You will directly go to the stage construction, which is basically the analysis window. Like you have seen in other softwares, you have to run analysis. In this software Plexus, they are using stage construction. Now, if you see on the left side of the screen, the first is initial phase. Now, this initial phase is representing the natural stage of the soil, that there is no load applied and you are going to compute only the stresses corresponding to the natural stage of the soil, which is, if you observe here, when I click on this initial phase, I can find only K not procedure, which is what you are computing the vertical stresses and horizontal stresses based on the ranking static coefficient, uh, which is your initial stresses. Now, after the initial stresses, there will be application on of the load, which will give us the change in the stresses or the total stresses. So what I have to do is I have to click on this on the left side. If you see my cursor, I have to click on add new phase, which is a loading phase. So I will click on this one and I will name it as settlement, because we are applying a control settlement on this phase, and this settlement will start after initial phase, when you have your natural soil profile, your natural stresses, initial stresses which are available. After that, I came and I constructed a foundation on that one, and that foundation is causing the settlement in the soil. Now, there are different type of calculations through which you can solve this problem. You can see here plastic or safety. Now, what we are going to do here, if you see on the left side, right side of the screen, elastoplastic drain and undrain analysis, it does not include the consolidation. For consolidation, we have another method, because I'm using now here more Coulomb approach. So clay consolidation or other things, you have to define from the beginning what type of model you have to use. Now, for safety, you can see here calculation of the global safety factor by means of strength reduction factor. The mesh is not further updated after safety analysis. So basically here, what you are doing is you are applying a factor of safety on the strength of the soil. But I just want to get Q ultimate, and I will do my self factor of safety at the end. So I will choose the plastic analysis, which will what will happen when I will apply a load on the soil. The soil in the beginning, it will carry some forces and it will be in the elastic zone, and then when you increase that load continuously, what is going to happen, the soil will move towards the non-linear stage where there is no chance of returning back to its original position. So we will move into the failure zone. So rest are all default options. You don't need to change that one. You can just say OK. Once you say OK, you already define the phase, which is settlement. But if you observe here, when I'm in the initial phase, on the left side of the screen at the bottom tree, you will find that geometry is checked. Surface displacement is not checked. Soil is required. All the We need to go to the settlement part and click on check surface. If I don't check this one, means there is no surface load applied on this point. So once I created a new phase for the analysis, I need to click on surface displacement. When you check this one, you can see here some green arrows are appearing on that location where you apply the settlement. Now your model is almost ready, but what is the important thing here? We need to record the data. Now, when you will apply this displacement, you need to get forces against some specific point, against some specific location. So if you observe here, this is the point. The next option, which is points with the triangle, it's indicate us to select a point for the curves. So you need to record force versus displacement for that specific point. So when you click on this one, a new window will open for us, and it will show us all types of nodes in our model. Now I will go to the initial node, which is close to 0.00. I will click on that one and it will show the node number, that this node is numbered as 5. And I need to record all its data from when we are going to carry out the analysis. So if you see here, it will record, I have selected this node and data will be recorded for that one. But you don't have to close this one. You have to click on update. If you just close that one, this node has not been recorded. So I will update that one. Once I will click update, I will go back to the same window, and now the software will record the data for that node. After finishing this one, I have to calculate the results or solve the problem. So you need to click on this integration average mark, or you can say that calculate. Once you click on this button, you will see that now the software is running some analysis. If I have more number of elements, this analysis will take more time. Now, in this case, what I did is I used medium elements. So you can see that still it's taking too much time, and how much memory it has been used. Around 200 MB memory will be used for the solution. Now, once that window is gone away from us, means the solution has been done. After that, we need to see what we need to see the results. Now, how we can see the results? Next button after the integration mark is the search button, which shows us view calculation of the results. When you click on this one, a new window will appear in front of us. And if I just zoom that one, you can see here when we apply a displacement of 200 millimeter or zero point 0.2 meter, your soil surface has been moved downward 200 millimeter. Now, what is the important things when we are analyzing that one? You need to see the deformation stresses in the soil. Now, first thing, I will see the deformation. Now, I will see the total deformation in Z direction. When you click on this one, you can see here now how your soil is behaving. Now, these contours are showing us that we have higher deformation near the top surface. Then this deformation is reducing and reducing and reducing. And this is how our stress bulb is also forming. Now, more is the deformation, more will be the stresses there, and less will be the deformation, less will be the stresses there. So you can see here on the right side of your screen, there are the units shown here. So if you observe here, minus 222 into 10 to power minus 3 meter, means red is indicating zero point 0.22 meter displacement, and blue is indicating 0.002 meter. 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 0. meter. And you can see here the minimum value here is 0.02 and zero point 0.2 is the maximum. So negative because we have displacement in downward direction. So that is how you are getting the maximum displacement. Now, you can come here, you can see the displacement in x direction. You can, because when this is going to move downward, there will be a displacement in the surrounding soil. You can see in y-axis in the other direction. So this is how you can see the displacement in different direction. Now you guys need to explore all these options when you are using. For the time being, I'm just recording the displacement, and you can see the strain in the other direction. If you want to see the strains, you want to see the principal strains, and you want to see the strain in the other direction. So you can explore all these options by contours or by contour lines, whichever option you like. Now, if you remember, I started recording one node for the results. Now I want to see the force displacement curve, because from the force displacement curve, I can figure out the bearing capacity of this soil. Now, if you see here, the fourth button is indicating us curve manager. When you click on this one, you need to click on new, and you will find on x-axis what you want to plot. I want to plot forces in z direction, and on y-axis I want to plot the displacement for that node which I selected. Now when you select that node, you will find deformation here. What deformation you want to record? I want to plot between z-axis, and if you observe here, when I click on that one, it's showing me the curve here, which is displacement versus force. Now, if you see here, here it's representing us vertical displacement on y-axis and your forces on horizontal axis. Now, this graph is very important for us for the computation of the bearing capacity. Now, I need to take this graph to the Excel sheet, and from that I will convert these forces into stresses, and from that stresses I can figure out the bearing capacity of the soil. Now, if you click here on the table, you will see that our data is given to us for forces when displacement is zero, force is zero. When displacement is 0.001, force is 171.33. And this way we will get all our, when you reach 2.2 meter displacement, the force in the soil or at that node was 5,413 kilonewton. What I will do, I will select them all and I will copy that one and I will go to the Excel sheet. Now I will bring that results here. I will paste that one, and I will just convert these into general, because I don't want scientific notation so that we can see the numbers. Now, this column is representing U, which is vertical displacement, and this is representing us the forces. Now, I will convert these forces into stresses. Now, what was the area we designed in the software? The area which I consider in the software for the foundation, because I model only 1/4 of that one. So the area was 1.5 by 1.5. To compute the stresses, what I will do, I will divide force, this force by 1.5 times 1.5, which is actually 2.25, but I'm just showing you guys here. So I will just compute all the stresses. This is the stress. Now, what I will do, I will plot the graph between the displacement and the stress. So displacement is shown in negative. So I'm just converting that into positive so that I can see the displacement and the forces through the positive axis. Now I will come here and I will plot that graph again. It's the similar graph. You will find the trend will be the same what you have observed there. But why I'm doing that one, you guys will figure out now. The main target here is to compute the bearing capacity. Now on x-axis, I'm going to show you the displacement, and on y-axis, I'm going to show you the forces or the stress. Now, if you observe here, this is what our load or stress displacement curve. Now, if you remember, this is, let's say, if I just want to rotate that one, but it's not possible here. But just to give you an idea, what is happening here, your displacement, when you started with the displacement increment, your force is increasing. Now you can see here what is happening here. Your with the increment in the displacement, your curve is now becoming flattening. Now, when your curve is flattening means that your soil is already failed. It's not carrying now more load, and once you reach to the ultimate load, now the settlement is becoming almost constant. Now, in our second chapter, when we learn about the exploration and we carried out the plate load testing, and I told you that through that load displacement curve you can find the bearing capacity. So we are going to use the same concept here. What I will do here, I will use a tangent. If you don't have a smooth curve or pure flattening curve, you can draw a tangent by considering your points on your graph, and wherever they are intersecting, you can go on the y-axis. It will give you the maximum bearing capacity at failure and the maximum settlement which you can consider about that failure point. Now, this is the ultimate bearing capacity calculation through the load displacement curve. Now, if you observe here, if I just zoom that one, the value is around 100, 1,800 or 1,750 kPa, because this is stress. I'm showing here stress unit here is kPa. So if I just go back to the PowerPoint, now using the Terzaghi equation, you can see here what bearing capacity we are getting. We are getting around 1,077 using the material properties. So your finite element software is giving us now ultimate, and that is more accurate analysis. These Terzaghi equation, Meyerhof equations are approximate equations which gives us the bearing capacity by approximate method. So from the Plaxis curve, we got bearing capacity equal to 1,785. Now that is representation of your ultimate bearing capacity. Now what you can do here is you can apply no factor of safety on this one depending on your choice. If you as a designer you want to keep you want to apply less load, means allowable bearing capacity. So allowable bearing capacity, if I'm taking factor of safety equal to 3, so I just need to divide this by 3. So you will get around 595 kPa is your allowable bearing capacity, and if you just apply to on the Terzaghi equation, you will find you will find that it is around 359. So 359. Now, what you did in the Plexus software, you carried out the exact solution through the finite element approach, which is giving us this bearing capacity. Another thing is that as a designer, if you want to limit the settlement in your soil or under your foundation, so you remember that there was some limitations given to us. If it is a shallow foundation, I can limit my settlement, uniform settlement up to 25 millimeter, which is 0.025. So you can directly see the stress here against that settlement, which is around 849.48, which is the ultimate capacity corresponding to the 25 millimeter settlement. And you can divide this by 3, and you can reduce your um, allowable capacity up to 283. So you can see how you can figure out the bearing capacity now directly from the usage of the Plexus 3D software. So this is a simplest example. I just brought it here. And if you guys have any questions, I will just take now questions, and then we'll see the other thing if we have enough time to go through that one. So I believe you guys got this modeling stuff now, and we can go through the questions and answer if you have any questions and answers now. Yes, guys, any questions about the modeling part, or if you get if you don't get anything?
It is okay, Doctor.
Anyone have any question? I believe it's straightforward now. What you guys can do is you can practice on this software. I will share the link with you guys. You install that software in your computer and take chapter 3 or bearing capacity chapter, and try to model the problems which we solve in the class. And with one or two practice, you will be able to understand how to use this software, and then you can work on your project which will be related to the Plexus. So this is the time. If you have any questions, you guys can ask now.
Thank you, Doctor.
Okay, there is a question from Ibrahim that how to put the dimension in the structure when we create a surface. So can you just elaborate, Ibrahim? You are talking about the surface creation, this part. I will just share the screen. So are you talking about this part? Yes, Ibrahim. Okay, if you go to the structural zone, if you see here on the top left side of the screen, the first one is soil, second is the structure. When you click on the structure, you will find the options here to create a surface, or you want to model a line, or you want to create a curved surface also. So there are multiple surface available. Now, I already run the analysis, but when you click on this surface, you can see here a node is running here and there. You can click at any location and start modeling your surface. Now, when I do that one, I'm just choosing random numbers. But in reality, my numbers are not these. So what you can do, you can go to the right side of the screen and put your four nodes, because for a rectangular surface, you need 4 points. So you can come here and edit your point according to the size of the foundation. So here we have 0, 0. Then you can come here and put 1.5, then 1.5 and 1.5 and 1.5. It will create your rectangular surface, and then you click on OK. Your rectangular surface will be ready. Is this point clear? Guys, anyone have any question related to that one? If it is all clear, then I need to conclude here, and I will share the link of the Plaxis through this chat, and you guys can just download directly from the chat. So before leaving, just take the link and just give me a minute. I'm just going to share the link with you guys, uh, and then you guys can just download directly from there. So give me a minute. Okay, guys, I'm sharing the link here in the chat. Please try to open this link and let me know if it is working and you are all able to download the software. So just click on that one and start down. Check if it is working and you are able to download.